All right, hi you guys, welcome. We'll be talking about graphs of rational functions today, and we're going to be writing them out. We're going to be using Desmos quite a bit. Okay. Well, you can use Desmos, but I also want to show you by hand how to find them. So let's go. Before we get to Desmos, let's talk about the vertical asymptotes, the horizontal asymptotes, and the slant asymptotes. Okay, so the vertical asymptotes are found by finding the restrictions of the denominator. Okay, so if you find the restrictions of the denominator, you have your vertical asymptotes. Let me get that to be capital A. All right, now horizontal asymptote, I like to use rules. I mean, there's a method in the book. I'm not a big fan of it. You know, it's just right there. It's just like blah. You know, it's right there. So I like to look at the degree. Okay, if degree of polynomial on top is less than degree on bottom, okay, your horizontal asymptote is going to be y equals 0. Okay. All right. If, let's say the same thing, pretty much, let me see, copy. Let me see, if degrees are the same, horizontal asymptote is going to be y equals leading coefficient on top divided by leading coefficient on bottom. Okay? And to do the inverse of the top, if the degree on the top is greater than the degree on the bottom, no horizontal asymptote, you must go to slant asymptote. Okay. All right, so that's very, very, very helpful when working with this stuff. Okay, now the slant asymptote is found by dividing the top by the bottom. And let me double check just to make sure. Yep. Dividing the top by the bottom and your non-remainder portion is the slope of the slant asymptote. Okay, so this one's going to take some time to practice. So let's start taking a look at some. So let's say f of x is equal to, let's say 1 divided by, and I'm going to write these out in longhand form just because it's too hard to construct by drawing it and stuff, x plus 5. Okay? All right, the first one I like to do is the vertical asymptote. So the vertical asymptote is going to be x equals -5 because that's the restriction. Okay, so that one's pretty simple. Now the horizontal asymptote is going to be y equals 0. Why? Because the degree on the bottom is bigger than the degree on the top. The degree on the bottom is 1. The top is 0, so the degree on the bottom wins. Okay. Now f of x, let's say it was, let's say -1 divided by 2x. Okay, something like this. Okay, the vertical asymptote would be x equals 0. Why? Because the only restriction on the bottom is 0. Okay. The horizontal asymptote would also be a variation of that. It would just be y equals 0. Okay. And you can graph the rest from this just knowing this. Now, obviously, you would have to pay attention to the fact that you need to make it upside down because it is negative. So you would flip about the x-axis. Okay. So that's something simple. All right, let's go. I did forget one thing, and I just looked at my notes, and I was like, oh man, I forgot. Or, okay, now if you are in standard form, this works. This method works of following the horizontal asymptote. Okay, so standard form works there. Now, if you're in vertex form, vertical shift is going to tell you it as well. So, for example, f of x equals 4 divided by parentheses x minus 3, and then I have off to the side plus 5. Okay, normally my vertical asymptote is still the same, so nothing changes. So x equals negative or positive 3. Okay, but my horizontal asymptote is going to be, normally it's going to be y equals 0, but I now have a plus 5 on the outside. So it's going to be y equals 5 for this circumstance because of the vertical shift. Okay? Alright, now what if we were taking a look at something where the degrees were the same on top and bottom? So let's take a look at f of x is equal to, let's say x, no, let's say 4x squared plus 1 divided by x squared. Okay, something like that. If you notice the degrees are the same, my vertical asymptote still stays the same, and it would be y equals, or vertical asymptote would be x equals 0 in this case, because 0 would make that a restriction. Okay, now my horizontal asymptote would be the leading coefficient. So it would be y equals 4, which is the leading coefficient on top, divided by 1, which just turns it to 4. Okay, so that's where I have to follow this rule. Okay. All right, now let's say if we go to the next part, and let's say we actually had a slant asymptote. Okay, so let's say we had f of x equals x cubed plus 1, and this was all in parentheses. I like to put in parentheses when I write it out longhand like this, just because it helps me organize my thoughts, divided by x squared. Okay? Alright, so the vertical asymptote's still there. Vertical asymptote is x equals 0, so that's pretty easy. However, there is no horizontal asymptote. However, when there is no horizontal asymptote, I do need to find a slant asymptote. So if I had to do it, I'd do division. Okay, so I'd write out a division problem. So I got my divisor here, and I would have x squared here, and I would have x cubed plus 1. Okay? Alright, so I would need to ask myself, okay, what do I need to, well, in actuality, I would probably need to fill in all the data as we go. So I'd probably need 0x squared, okay? And then on top of that, I would have plus 0x, and then I would have the plus 1. Okay, so how many times does x squared go into x cubed? It goes in x times, because you times those two and you get it. Alright, so if I times this by x squared, I'm going to get x cubed. Okay. Alright, and that's pretty much it. So when I go to subtract it to go to the next part, okay, So I'm subtracting 0, 0, 0. I'm just left with 1. Okay, my remainder is 1. And I write it as 1 over x squared, okay, because that's how you write the remainder. But the slope of the actual slant asymptote is just going to be this. So my actual slant asymptote is going to be y equals x. And ta-da, I've done it. So that is actually how I do it by hand, okay? And you are going to need to do that if you use Desmos too, because Desmos is not going to point it out. Okay. All right. And once again, you are going to have to remember your long division for this. I'm not going to do another one because I'm almost out of time. But use long division or synthetic division. It depends on what you like. Like for example, if I had to do this one, you know what? I'll set it up so that you guys can see it. We've got parentheses 2x squared minus 3x plus 1, parentheses, divide by x minus 2. Okay? Alright, so my vertical asymptote would be x equals 2, so that's pretty easy. No horizontal asymptote because the degree on the top is larger. The slant asymptote I would use, I would use synthetic division just to set it up. Okay, so I'd have the 2 here. Okay, I have 2 up top. I have negative 3 here. And I have 1 here. Okay, so I bring down to 2. I times it by 2 to get the 4. 4 plus that is 1. Okay, and then I times that by 2 again. And I get 3. Okay, so what is my actual slant asymptote? Just from reading it, y equals 2x plus 1. Okay, and once again, you always ignore the remainder when you're doing the slant asymptote, so you don't need this right here, so blah. Okay, all right, guys, that's it for the form of working with rational functions. Desmos should be really easy just to work with. On this, you are going to have to test out your slant asymptotes, your vertical and horizontal asymptotes with a graph just to make sure you're right. Okay? Thank you guys very much and have a great day. Bye.